Graphics, optimal start. I'll read through these dot points and then we'll talk about it like usual. Do you know how well your optimal start control strategy is working? Are the floors achieving their target temperature early, late, or on time? How much power are you using during optimal start? What is the point of providing an optimized control strategy if we're not going to study it, analyze it, tweak it? Why am I suggesting you build this graphic? Pause and think about it. So I'll just talk for a couple of minutes about these dot points while you think about that last question, which I will talk about in the next slide. Why am I suggesting that you build this graphic? Pause and think about it. All right, so the first point there, do you know how well your optimal start control strategy is working? And I would suggest the answer is no. I have never ever seen a BMS company produce any sort of visualization or analysis around optimal start. There's no dedicated optimal start graphic, which is what this lesson is actually about. There's no advanced trends, groups of trends for the optimal start. There's no alarms to give you a warning to say, hey, the optimal start failed this morning. It did not achieve target temperature, within 15 minutes of occupancy time, whatever. And there's no reports. There's no report that gets issued once a month that you could run that shows the performance of the optimal start over the last month. How did it go from Monday to Friday? Did you achieve target temperatures at 8 o'clock? How much power did you use? So the first thing is, no, I don't think that we know how well our optimal start control strategy works, which is kind of like disappointing because we spend a lot of time writing the software code for it and then downloading it and testing that it functionally works. We test that it functionally works, the time schedule, the optimal start, the outside air temperature, and that it then requests the AHUs to start an hour early and the boilers and chillers, whatever it is. We test that the optimal start control strategy functionally works, but I don't think we tune it moving on from there and actually check, is it working the best way it can? Can we improve it, make it a bit better, save more energy? We don't do that, I don't think. Are the floors achieving their target temperature early, late, or on time? And the third one, how much power are you using during optimal start? There's basically two purposes for optimal start. One is we need to air condition the building before occupancy, so when the tenants arrive on site, it's comfortable on their floor. So in winter, we are going to preheat the building for half an hour, an hour and a half, whatever. We preheat the building in winter so it's comfortable, and we pre-cool the building in summer so it's comfortable. So priority one is this thing needs to work so that we have comfortable temperatures at occupancy and the tenant is happy to pay money for their rent because the landlord is meeting their requirement of providing air conditioning during the tenancy hours. And the second thing is we need to save energy, because obviously you could just say, look, we'll just start the building 4 hours early every day. Or if I exaggerate that, just run the building 24/7. If the building runs 24/7 or it starts 4 hours early, you're definitely going to have comfortable temperatures at 8 a.m. Absolutely. You've ticked that box, comfortable temperatures, but you're using a lot of power to do that. So there's always this trade-off for optimal start where you're thinking about, I need to provide air-conditioned conditions, comfortable conditions, comfort control, but by using as little power as possible. And that's why if you do the optimal start course, it talks about just preheat the building to 21 degrees Celsius and pre-cool the building to 24 degrees Celsius. Those are the least conditioned temperatures. Do not heat the building to 22 degrees Celsius if 21 is going to meet the contractual agreement. And don't cool the building down to 22 if cooling it down to 24 meets the contractual agreement between the landlord, the building owner, and the tenant. So optimal start's kind of difficult because you're always fighting the battle of comfort control and achieving that using the least amount of power possible. The fourth point, what is the point of providing an optimized control strategy if we're not going to study it? So this is probably a longer discussion, but if you're not going to get this, if you're not going to study this thing and make sure it works properly, like what's the point of providing it if it's not working very well? That might make more sense as you work through this. So I'm going to go to the next slide now. So the last point was, I want you to think about, why am I suggesting that you build this graphic? So why am I suggesting that we need an optimal start graphic, and also trends and alarms reports? Those are different topics, different lessons. Why do we need an optimal start graphic? So second dot point, you need the graphic not just to assist you in the tuning of the optimal start software, but to prove to the owner that what you're doing is working, that they're getting value for money, and that you should be rewarded. To get rewarded, you get rewarded with approvals for future optimization free proposals you submit. So if you prove that you know how to do optimization professionally, and you have this graphic that you use to tune the system, but you can also use to prove the owner the thing works. And then you get rewarded. And they will then think, look, this company is really good. They're very professional with optimization. They do the design up front. There's a measurement and verification piece, and they can prove to me that it works. They then approve other free proposals you put in for peak demand management, demand control, ventilation, upgrade the chiller control system, AHUs, whatever it is. You get rewarded when the high value BMS maintenance contract is renewed every year. So you might have a very expensive BMS maintenance contract. Maybe you're getting paid $200,000 a year, when really this building should just be $150,000 a year. So when you prove your value, the owner looks at that $200,000 and thinks, this is really expensive. Wow. This building has the highest BMS maintenance cost per meter square in the portfolio of 30 buildings, but man, we get good value for money. This company is really good. They keep re-signing that very expensive maintenance contract. You get rewarded with opportunities to upgrade other obsolete BMS systems in the client's portfolio. So you do a good job of this building, and then there's a BMS upgrade happening, 3 streets down in the city, and you're on that upgrade. You get an invitation to tender for that upgrade with 2 other companies or 3 other companies. You get opportunities because they want you in more of their buildings. BMS companies do not exist to save energy in buildings. They exist to make money. I'm not sure if we discussed that before, but we probably should. BMS companies do not exist. Actually, we discussed that, I think, in the beginning of the BMS maintenance course. BMS companies do not exist to save energy in buildings. BMS companies do not exist to make buildings more comfortable, more reliable. They don't exist for that. BMS companies exist to make money. So everything that you do, and a lot of people don't like this, has to have a money angle to it. This optimization, this optimal start graphic is a tool that you use to show your customer with their eyeballs. They look at the graphic, they look at the trends, and they can see that this optimal start is working. And they give you more money. You need advanced visualization to prove your value, not just to help you understand the performance of a system. So I'll just pause here for a second. So when I said to you, pause and think about why am I suggesting this graphic, you're probably thinking, well, it's kind of obvious, Bryce. We need this graphic to help us understand the performance of the control system, how well it's working or how poorly it's working, so we can adjust parameters on the graphic that make it better and make it work. You were thinking we need this graphic to help us better understand the performance of the control system. But you also need the graphic. This is a new idea, a new concept. We also need the graphic to prove that it works. All right. So if you provide an optimal start control strategy and you don't have this graphic, how do you prove it's working? How do you prove that at 8 o'clock it's 21 degrees Celsius in winter, or it's 24 degrees Celsius in summer? How do you prove that? If there's no graphic with a multi-point trend showing that bang. How are you gonna, you can't prove it. You can't prove it. The customer just have to trust you. They just have to believe you. If you just say it's work, they have to believe you. And the trust, unfortunately, is very low in the BMS industry between the owners, the facility managers, the consultants, the mechanical contractors, everybody, and BMS companies. And I apologize if you don't like me saying that, but the trust is low between the BMS companies and other stakeholders in the market. Last dot point, most BMS companies stop short of translating the service they provide into money. BMS companies are not good at proving to their customers that whatever it is they're doing, how it translates into money for the customer and for the BMS company. So these two slides are kind of interesting because they're actually very relevant to all control strategy optimization projects. If you're doing a peak demand management, optimization project, or a chiller management system optimization project, this applies. These two slides apply to all of them. I sort of like went off topic here because I was writing this out like about 3 weeks ago. And, even like this morning when I was preparing for this to record, I was thinking, Bryce, you've sort of gone off topic here. You should just show them the optimal start graphic. This is a graphics lesson. But I just wanted to just reinforce this point. And I'm sure I've discussed this in other ways, in other courses. I just want to reinforce right now why we need these graphics. If you're not producing these graphics, you're failing your customer. You're failing them if you don't have these graphics. So what happens if I come to your building as like an independent BMS reviewer, as I've described before, which I often am doing this often. And I'm in a meeting with, it's me, it's you, so maybe it's like the service technician, the account manager, the salesperson, and the customers there. We're all sitting there. And I say to them, can you log into BMS quickly? And you're like, yeah, sure. Just got the laptop here, plug the phone in, 5G. Yep. Can you show me and prove to me that your optimal start control strategy is working? What are you going to do? How are you going to answer that question? It's going to be very embarrassing. Oh, well, actually, I can't prove it to you. We don't have any graphics or trends or alarms or reports. And I'm like, oh, okay. Embarrassing. And then I say to you, well, while we're here, can you show me, can you prove that your air handling unit supply temperature reset strategy works and your supply pressure reset strategy works? And you're like, yeah, sure. And you'll show a graphic and you'll have the high pressure set point limit, the low pressure set point limit, it's resetting. And I'll be saying, well, where's the demand points? Where's the VAV damper positions? How do I know the dampers are, I haven't mapped those points. Or if I say to you, how's this? Warning, off-topic discussion approaching. If I say to you, well, actually, you know that an air handling unit's supply air temperature set point reset and the air handling unit's supply air pressure reset strategy are actually related to each other. In that if you drop the AHU supply air temperature set point, if I say 2 degrees, cooling valve opens, temperature drops 2 degrees. And you've got colder air going through the air handling unit duct system and down the floors. And there's colder air, 2 degrees colder air blowing out of the diffusers. And that temperature sensor on the wall, the VAV temperature sensor, when it detects that cooler air coming through, the VAV damper closes slightly, because it needs less cooling, closes slightly. All of the VAVs close off slightly, 5%, 10%, 15%, they're all closing off. The air handling duct pressure goes up above set point and the supply fan slows down and the return fan slows down. So there is a relationship, and kind of like indirect relationship, between the air handling unit supply temperature set point reset and the air handling unit supply pressure set point. There's an indirect connection between the two of them. Colder air slows the fans down, which saves energy. And then if I was a very mean person and I said to you in that meeting with the customer, okay, well, show me your air handling supply pressure reset and your temperature reset, and show me the analysis there around the optimization between how cold should that supply air be to save energy keeping in mind it's using more chiller pumping power. Wow. Okay, so that's a bit of an exaggerated example of a very complicated thing. I would never ask somebody that question in real life because it just would be so mean to ask that question. But really the point here is if you as an individual want to tell people that you're a control strategy optimization specialist, or you as a company, a BMS company, want to market to the industry that you are a optimization specialist, you need to have these graphics to support that. Because if you don't have the graphics, you're not a specialist. You're not a specialist if you haven't got the visualization to help you, provide you with information that your eyeballs can look at a graphic, look at trends, look at alarms, look at reports, and allow you to tune the system. How is this system negatively impacting that system? What is that relationship? And then also you need that visualization to show your customer, look what we're doing, it's working. This is what was happening 3 months ago, or the same time last year. We changed the control strategy. It's the same season, same outside temperature, and look how much better it is now. If you haven't got those graphics to prove to them, you're wasting your time, in my opinion. All right, let me show you a couple examples of some optimal start graphics.